research scholars, students, and participants from India and abroad to the International Conference on 2D Materials and Technology Global 2026. This international conference is a joint initiative of IIT Indore, UGC DAE CSR Indore, and RRCAT Indore. Over the next 3 days, this conference will bring together leading minds working at the forefront of 2D materials, science and technology, spanning fundamental research, advanced characterization, energy applications, electronics, photonics, healthcare, and emerging quantum technologies. We are truly honored by your presence and grateful that you all have joined us for this exciting scientific gathering. To formally commence the proceedings, I would like to invite Professor Rupesh S. Devan to kindly come forward and initiate the inaugural proceedings.
Good morning and very warm welcome to you all. Respected Chief Guest, Padma Vibhushan Dr. Anil Kakodkar sir, patron of this conference, and our Honorable Director Professor Suhas Joshi, C. Viraj Bhange, Director RRCAT Indore, Professor Kaustubh Pirolkar, Director UGCDA CSR, distinguished guests, eminent speakers, industry leaders, guests, my fellow committee members, my colleagues, Global Connect volunteers, dear participants, welcome to the inaugural ceremony of 2D MatTech Global 2026. Standing here at Nalanda Auditorium and looking towards you, occupied with brightest mind in material science, I feel with profound gratitude and immense pride. When you have friends who are always available to pursue your seemingly crazy idea, challenging tasks become achievable. I consider myself fortunate to have such colleagues and friends. About a year and a half ago, during discussion on challenges of novel max phase and maxine synthesis, we envisioned an ambitious goal, creating a global corridor here where we can have discussions on microscopic world to the 2D materials, meeting microscopic real-world solutions. Today, that vision has become a reality, born from collaborative efforts of our friends and colleagues at IIT Indore, RRCAT Indore, and UGCDA CSR Indore. This monumental task would have been entirely impossible without brilliant support from my colleagues, co-conveners, Dr. Ramjani Chaudhary, Dr. Ravindra Jagid, and my department colleagues from MMS and CIVIST at IIT Indore. Thank you for walking shoulder to shoulder with me through the late night planning sessions and every logistic puzzles. We live in the era where traditional materials can no longer solve our problems in energy, healthcare, defense, and quantum frontiers. 2D materials from graphene to traditional metal chalcogenides and transitional metal carbides are no longer just a laboratory curiosity. They are actively rewriting the rules of what is physically possible. Having Padma Vibhushan Dr. Anil Kakodkar sir with us today as our chief guest is singular honor. Sir, your lifetime dedication to India's scientific self-reliance and technological visions serve as an ultimate bright star for the gathering which is present here. Your presence remains our young researchers that science we discuss in the rooms has the power to shape nation and the global destiny. We express our sincere gratitude to our patron, Professor Suhas Joshi, for his unwavering support and encouragement through the planning and execution of this conference till today. We also extend our heartfelt appreciations to Director RRCAT and Director UGC DE CSR and the member of International Advisory Committee for their invaluable guidance and supports for this conference. To our international delegates who have traveled far to be in Indore, and to everyone joining us for across India to bringing your expertise, curiosity, passion to this platform. To our industry experts, let's work together to solve the range of scientific and technological problems. To our delegates, I urge you over the next 3 days to look beyond your scientific specific research fields. The most revolutionary breakthroughs always happens at the exciting intersection of different disciplines. Now, to formally begin the inaugural ceremony, may I respectfully invite our dignitaries on the dais, Dr. Anil Kakodkar, chief guest of this function, Professor Suhad Joshi, patron and director, IIT Indore, Sri Virajji Bhange, director, RRCAT Indore, Professor Kaustubh Pirolkar, director, UGC CSR, Dr. Ravindra Jangid and Dr. Ramjani Chaudhary, co-convener of this conference. Ladies and gentlemen, please join me in welcoming our dignitaries on the dais. Thank you. Congratulations.
Thank you, sir. Every meaningful journey begins with the pursuit of knowledge, wisdom, and enlightenment. In keeping with our rich academic tradition, we shall now begin the formal inauguration with Saraswati Pujan and the ceremonial lighting of the lamp, symbolizing the triumph of knowledge over ignorance and the illumination of mind through learning and discovery. May I respectfully invite our dignitaries to join the lamp lighting ceremony.
ब्रह्माच्युत शंकर प्रभृतिभिः देवै सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा। या कुन्देन्दुतुषारहारधवला या शुभ्रवस्त्रावृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युत शंकर प्रभृतिभिः देवै सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा। या कुन्देन्दुतुषारहारधवला या शुभ्रवस्त्रावृता या ब्रह्माच्युतशङ्कर प्रभृतिभिः देवै सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा।
May I request Director IIT Indore, Director RRCAT Indore, Director UGC DAE CSR Indore to please facilitate the chief guest. Thank you, sir. Now I request Professor Suhas Joshi, sir, to kindly present a bouquet and memento. To kindly present a bouquet and memento to Professor Kaustav Priyolkar, Director UGC DAE CSR Indore. Thank you, sir. Now I request Dr. Ram Chaudhary, on behalf of the organizing committee, to kindly present a bouquet and memento to Professor Suhas S. Joshi, Director IIT Indore. Thank you, sir. I request all the audience to give a huge round of applause to our esteemed guest.
(2D MatTech Global 2002) looks like in number, theme, and opportunities. This conference has $260 plus will be presented over next 3 days. All these abstracts will be considered for publication in Wiley through their standard pre-review process. Importantly, given the enthusiasm within 2D material research community and industry, we propose holding this conference every 2 years. To maximize impact, our technical sessions are meticulously organized into 4 parallel sessions: Science and Engineering of 2D Materials, Advanced Characterization Techniques of 2D Materials, Energy Applications of 2D Materials, and 2D Materials in Emerging Technologies, seemingly covering everything from fundamentals to applications. Following our highly successful pre-conference workshop, the main event features stellar lineup of expert lead sessions. We are privileged to host world-renowned visionaries, including Professor Umesh Wagmare, Professor Yon Ronma, Professor Jean Hockin, Professor Vijaymohan Pillai, Professor Satish Chand Ogle, Professor Vikramjit Basu, and alongside many other extraordinary speakers. Please excuse me for not including all the speakers' names in this brief list. You are close to our heart and deeply valued. One of our core objectives in championing early career researchers. To that end, we have partnered with Wiley to present a series of awards during our closing ceremony. This includes the Best Thesis Award, Best Oral and Presentation Awards to celebrate innovative work, scientific impact, visual excellence, and engaging communication. Thanks to Dr. Rohini from Wiley for her extraordinary efforts. Our parallel technical talks, oral presentation, and poster presentations are detailed in conference booklet. Please follow the WhatsApp group for real-time updates. Also, do visit our industry partners' stalls to explore current commercial innovations and challenges. Moreover, we are working for forming a 2D Materials Research Society India, and in this regards, we look forward to receiving your opinion and suggestions during next 3 days. Our volunteers are stationed everywhere to help you. Let's make next 3 days a benchmark for 2D materials collaboration. Once again, welcome to IIT Indore, welcome to 2D MatTech Global 2026, and I wish you all an incredibly enriching experience ahead. Thank you.
Thank you, Professor Devgan, for introducing about and giving an overview of the conference. Now, it's my privilege to introduce our director, Professor Suhashish Joshi. Professor Joshi is a distinguished academician and researcher. He is a fellow of several prestigious national and international academics, including Indian National Academy of Engineering, the National Academy of Science of India, Indian National Academy of Science, and the American Society of Mechanical Engineering. Prior joining IIT Indore as a director, he served as a Rahul Bajaj Chair Professor at IIT Bombay, where he has held several important leadership positions that includes Head of the Department of Mechanical Engineering and a Dean of Alumni and Corporate Relations. Professor Joshi had made significantly contributions to advanced manufacturing and machine science through his research, consultancy, and industry collaborations, for which he has received Best Faculty Award of Mechanical Engineering Department in 2007, as well as P.K. Patwardhan Technology Development Award in 2008 at IIT Bombay. Now, I request respectfully invite our director, sir, to deliver his welcome address. I request everyone to please give a huge round of applause for our director.
Thank you for introducing me, and welcome to all the participants to IIT Indore. It's our pleasure to host this conference. First of all, we are grateful to Dr. Kakodkar for immediately agreeing to be the chief guest for this conference. In fact, he was the chief guest of 2023 convocation. However, because of not having some health issue, because of some health issue, he could not come personally. He was online at that time. But this was a good opportunity for us to interact with him and showcase all the various things which are happening in IIT Indore. My warm welcome to Dr. Bhange, RRCAT Director, Dr. Pirulkar, DA, UGC Director, and other dignitaries on the dais and off the dais. I don't have to tell the importance of 2D materials because you are all experts in 2D materials. I will tell about the institute so that you know about the institute. We have done many innovations in the institute. One of them is a MTech program with RRCAT. And this program is on applied lasers, applied optics and lasers technology. In this program, the theory is actually taught at IIT Indore, and all practicals and project is done at RRCAT Indore. So this is a joint collaboration between our institute and RRCAT. Of course, there are many other professors are collaborating and working together in the Department of Physics and Materials with RRCAT. There are other programs, MTech programs like biomedical engineering program, which is with AIIMS Bhopal. And one other interesting program which we have is with a College of Engineering, Telecommunication, Military College of Telecommunication Engineering, Maho. So where the 30 army officers, they come to the institute and they learn, they take part in MTech in information systems and artificial intelligence. So whatever training, the practical things they do at their place, and again the theoretical part they learn at IIT Indore. We also have similar executive programs for Volvo Eicher, employees of Volvo Eicher, and other company Case New Holland. These are the curated programs for these company employees. We have started almost like 8 new BTech programs in the last 4 years, and important among them is the engineering physics in the Department of Physics, which is again on the similar lines as that of the engineering physics program, BTech in engineering physics program at IIT Bombay and other institutions. But we also have BTech in space science and technology. So from the beginning we have physics and we have space science and engineering department, 2 different departments are there. So these two departments together, they teach these 2 programs collectively for first 2 years, and after 2 years these 2 programs separate in engineering, physics and the space science and engineering. We also are going to launch this year 2 important new programs, one on BTech in biomedical engineering and health informatics, and another on BTech in environmental economics and sustainable engineering. So these are some of the new age programs. We realize that today's students are not single-minded. They want a variety, knowledge in variety of fields, rather multidisciplinary fields. It's not the interdisciplinary, it's multidisciplinary fields. And each of these programs have kind of core structures in such a way that the students can go from finance sector to artificial intelligence to core research to fundamental research. Whichever they, the stream or whichever direction they would like to choose, there are vast gamut of the opportunities which are possible. So we have many things to showcase in the institute. Please visit our laboratories. One of them is the Maker Space Laboratory. I will urge the organizer, Dr. Rupesh, to organize a visit in our Maker Space. This is the replacement of age-old traditional workshop technology in our engineering syllabus. I was fortunate to establish it at IIT Bombay. It took me 4 or 5 years at IIT Bombay, but here it happened within 6 months. We could establish a maker space. So it's a completely different ball game. We have all tabletop, tri-type of machines in the workshop. There is no heavy lathe, all lathe, milling, drilling, everything CNC, and it's only a 1 feet by 1 feet machine. These are very small machines. There is no training required. The students can start using it from the day number 1. Apart from that, there are lasers, there are 3D printers, and the students do different kinds of exercises compared to the old age of fitting and carpentry. Here they develop most advanced devices in the first year itself, which has everything: computer programming, interfacing, sensors, connection, you name the technology, and they actually learn, or they are exposed in the first year. And that's where a new innovation is done, and I urge all of you to visit our maker space when you are here. But again, most welcome, my heartiest welcome to you to this conference, and hope you will have wonderful deliberations during your stay at the Institute. Thank you very much.
Thank you so much, sir, for your informative address. Now moving ahead, it's my privilege to introduce Professor Kaustav Priolkar, Director of UGC DAE CSR Indore Center. Professor Priolkar is presently the Director of UGC DAE Consortium for Scientific Research Indore. He is also a Senior Professor at the School of Physical and Applied Sciences, Goa University. He received his MSc and PhD degree from Goa University. His PhD work was on inelastic neutron scattering studies of cerium-based Kundo systems. His research activities are concentrated around studying different functional materials using X-ray techniques. He received the prestigious MRSI Medal Award in 2015. He was a visiting professor at the Chimay Paris Tech, Paris, France, and the University of Duisburg-Essen, Duisburg, Germany. Presently, he is also a member of several national-level committees, including the National Steering Committee of DST-DESI Program of Cooperation for Patra 3 Utilization. Now, I invite Professor Priolkar sir to address the gathering.
Thank you for this introduction. Good morning to you all. Padma Vibhushan, Dr. Anil Kakodkar, Chief Guest of today's function, and Chairman of our Governing Board, Professor Suhas Joshi, Director of IIT Indore, Shri Viraj Bhange, Director of RRCAT, conveners of the conference, distinguished invitees, eminent scientists, faculty members, researchers, and dear students. It's a great pleasure to welcome you all to this 2D MedTech conference on behalf of UGC DAE Consortium for Scientific Research. At the outset, I must congratulate the organizers to put together this confluence of eminent experts from not only from academia, but also from industry for this conference, because this is something very rare. And I hope this confluence actually gives rise to new cooperations amongst academia and industries. The UGC DAE Consortium was established about 3 decades back with a mission to provide access to these sophisticated facilities of the Department of Atomic Energy to the university researchers. So this was an attempt by the UGC and the DAE to uplift the research that is going on in our universities and colleges. Over the last 3 decades, we have done just that. This institute today, caters to more than 1,000 researchers from different universities and colleges, spanning from Kashmir to Kanyakumari and from Gujarat to Northeast, coming to our 4 centers, the Indore, which is the biggest center, at Mumbai, at Kalpakam, and at Kolkata. All these 4 centers are established basically with a view to provide access to the facilities like the synchrotron at Indore, the neutron scattering facilities at Dhruva in Trombay, and the cyclotron and accelerator facilities at Kolkata and Kalpakam. In addition to providing this access, we also have developed our own facilities. At the synchrotron, we have 2 beamlines which are constructed and run by our own scientists, and a 3rd beamline which we are running for Saha Institute of Nuclear Physics. At Mumbai also we have our own spectrometer, a powder diffractometer, which is the best available at Dhruva, and also it competes with the best in the world. In all these facilities that we have, the primary goal is to have low temperature and high magnetic field access. At Indore also, LTHM forms the theme area that runs across all our facilities, in-house facilities that we have developed. We have X-ray diffractometer, which you can do not only at 2 Kelvin, but also in presence of 8 Tesla magnetic field. We have Raman, which you can do at low temperature and in presence of magnetic field. We have the only Mossbauer low temperature and high magnetic field Mossbauer facility in the country. Apart from that, we have huge gamut of PPMS or facilities for recording transport and magnetic properties of different kinds of materials, all going down to millikelvins in temperature and about 16 Tesla in magnetic field. We also have array of thin film growth techniques and characterization techniques, and some even in situ characterization of thin films at our Indore center. In the recent years, we have also developed facilities for single crystal growth and characterization, which include the Love's diffractometer and also the 4-circle diffractometer, which are recently installed at Indore. Going forward, at our new building of Mumbai Center, we are in a process of getting an atomic resolution electron microscopy facility and a 3D atom probe tomographic facility, all this for the use of university and institute academia. So I welcome you all to UGC DAE consortium. While you are at Indore, you can please visit our Indore center, which is about 25 kilometers from here. You can see the facilities for yourself, or at least visit our user portal, csruserportal.com, which gives the information about all our facilities, as well as the facilities that we provide access to from RRCAT, the synchrotron beamlines, and the neutron spectrometers from SSPD BRC. Although it was formed for giving access to university researchers, over the years we realized that an ecosystem has to be developed which includes not only researchers from universities, but also from national institutes. And as I look around, I see many users from IITs and other institutes who are present here today. So this ecosystem now we plan to expand to national labs of CSIR and other government organizations, and later on to industry. With the constant encouragement from our GB chairman, Dr. Anil Kakodkar, we are now opening up our facilities for industrial use, and hopefully very soon we will have industry users coming to our centers and using our facilities. I hope that this conference allows you to bridge these connections, and we would be very happy to be the intermediary for the confluence between industry, academia, national labs, and all the 4 corners of our scientific research. Again, once again, I welcome you all to Indore, and I hope you all have a very enriching conference, and wish you all a very successful and successful stay here and conference here. Thank you.
Thank you, sir, for your inspiring words. Now, moving ahead, it's time to honor and introduce Shri Viraj Bhange, who is currently the director of Raja Ramanan Center for Advanced Technology, Indore. Shri Viraj graduated in electronics engineering from Shivaji University, Kolhapur, and joined the 34th batch of prestigious BARC Training School in 1990. Following his training in nuclear science and engineering, he joined RRCAT in 1991 and has since devoted more than 3 decades to the development of advanced laser and accelerator technologies. Over the course of his distinguished career, he has made significant contribution to laser instrumentation, data acquisition systems, accelerator control, instrumentation, and beam diagnostic. He has also led the laser control and instrumentation division and later the electron accelerator group. It plays a key role in the operation and advancement of Indus 1 and Indus 2 synchrotron facilities. Since January 2006, Shri Viraj has been serving as a director of RRCAT, providing leadership to one of India's premium institutes for advanced research in lasers, accelerators, and related technologies. Now, I request Shri Viraj P. Bhanit, sir, to address the gathering.
Thank you very much for kind introduction. Namaskar. Honorable Chief Guest of today's function, Padma Shri Dr. Anil Kapurkar, distinguished dignitaries on the dais, I extend warm welcome to you all participants who have joined us from various institutes in India as well as abroad. This conference is dedicated to rapidly evolving field of 2D material. The discovery of graphene and subsequent exploration of two-dimensional materials have transformed material science over the period of time. As you are aware, these 2D materials exhibit extraordinary electrical and optical, mechanical, thermal, and quantum properties. These materials open up new opportunities for next-generation electronic devices, energy storage devices, sensors, catalysts, etc. Since this 2D material are few atom thick, their properties are strongly influenced by defects, interfaces, strain, and electronic structure. It is worth mentioning here that synchrotron radiation sources serve as an eye for 2D material research, allowing scientists, researchers to see and understand the phenomenon that are otherwise invisible. Conventional laboratory techniques often lack the sensitivity needed to fully characterize these materials. Synchrotron radiation sources are playing crucial role in development of 2D material because they provide extremely bright, tunable, highly collimated X-ray source that can probe material down to atomic and electronic level. At Raja Ramanna Center for Advanced Technology, we have India's only 2 synchrotron radiation sources which are operational in the round-the-clock mode since year 2010. We have 20 operational beamlines for user experiments at RRCAT. Researchers can utilize these beamlines for characterization and study of 2D material. Some of the techniques which you can explore over here are X-ray diffraction, X-ray absorption spectroscopy, X-ray photoemission spectroscopy, angle-resolved photoemission spectroscopy to provide critical information about optimizing these 2D devices for your application. A pre-conference workshop was held yesterday at RRCAT to demonstrate these techniques to the young researchers and students of the conference. I take this opportunity to welcome scientists, researchers, students from India to utilize Indus 2 for the studies research at Indus 2. As Indus is a national facility, DA is offering these beamlines free of cost for the academic user. Apart from that, we are also providing these beamlines for industry users. We usually conduct various user meets for industry users, and we welcome everybody who can use this facility for their research. I am confident that this conference will provide valuable platform for scientists, engineers, students to exchange these ideas, present their work, and foster collaboration in the field. I am pleased to see participation of young researchers, students whose creativity and enthusiasm will shape future of this field in India. I would like to express my sincere gratitude to the organizing committee and all those who have worked tirelessly to make this conference possible. Once again, I also thank invited speaker for accepting our invitation and for sharing their experience during this conference. I wish you highly productive and successful conference ahead. Thank you and Jai Hind.
Thank you, sir, for your valuable words. We shall now proceed with the release of the conference abstract booklet, which showcases the diverse scientific contributions being presented during 2D MadTech Global 2026. The booklet reflects the collective efforts of researchers, scholars, and experts working across 2D materials science and technology. May I request our chief guest, Dr. Anil Kakodkar sir, to kindly unveil the conference abstract booklet. Thank you, everyone. We are indeed privileged to have among us one of India's most respected scientific leaders. To formally introduce our chief guest, I invite Dr. Ram Chaudhary sir at the podium, please.
Namaste, Namaskar, Shubh Prabhat, and good morning to all of you. Honorable dignitaries on the dais, distinguished plenary and invited speakers, respected participants, delegates of the conference, my dear colleagues from IIT Indore, RR CAT, and UGC DA CSR, students and dear friends. Around 2000 years ago, one of the greatest philosophers and scholars, Kautilya, mentioned in his Niti Shastra written in Sanskrit, Swadeshe pujyate raja, vidwan pujyate sarvatra, which translates to in English, while a ruler is worshipped in his country, a scholar is worshipped everywhere. We are really honored to have one of the most illustrious scholar, scientist of our era, Dr. Anil Kakodkar ji, among us for this inaugural session. And I feel really privileged to mention a few words about him. Frankly speaking, talking about his scientific accomplishment, his achievements before him is like showing a lamp to the sun. Therefore, I must seek your forgiveness for the limitations of my words, which will fall short of really capturing his scientific accomplishments. Yet I try and dare. Dr. Kakodkar ji joined BARC in 1964 at the age of 21 years. He became the director of Bhabha Atomic Research Center in 1996. He has also served as the chairman of Atomic Energy Commission and secretary of the Department of Atomic Energy, where he played a vital role in advancing India's indigenous nuclear energy program. He immensely contributed for the development of the atomic energy and nuclear power program in India. He has contributed immensely to the establishment of National Institute of Science, Engineering and Research, DAE Mumbai University Center for Basic Sciences and Homi Bhabha National Institute, which brought in linkage between basic research and technology development. His outstanding work has been recognized through numerous prestigious honors. He is a recipient of the Padma Shri, Padma Bhushan and Padma Vibhushan, among India's highest civilian awards. He has also received numerous distinguished scientific and engineering national and international honors, honorary doctorates by leading institutions, several academy fellowships in recognition of his exceptional contribution to science, engineering, and nation building. Beyond his scientific achievements, Dr. Kakodkar is also admired for his firm commitment to self-reliance, innovation, and the development of future generation of scientists and engineers. His life and work stand as a shining example of dedication, excellence, and service to the nation. Today, we are really fortunate to have you among us, sir, and to listen you. On behalf of everyone present here, I express our sincere gratitude for gracing the inaugural session of 2D materials. Indeed, the journey of matter to energy, or the transformation of one into another, seems quite seamless and meaningful in his presence, as he is blessing the conference with his gracious presence as the chief guest. With these words, may I request Dr. Anil Kakodkar, sir, for his address.
Thank you for that very gracious introduction. Professor Suhas Joshi, Director, IIT Indore, Shri Viraj Bhange, Director, Raja Ramanna Center for Advanced Technology, Indore, Professor Kaustubh Privalkar, Director, UGC DAE Consortium for Scientific Research, Professor Rupesh Devan, who has very painstakingly put together this conference, and also co-conveners, Dr. Chaudhary and Dr. Jangir, distinguished participants, invited speakers, ladies and gentlemen. First of all, I must express my deep sense of gratitude for this opportunity to be here. I must express my joy for putting together a meeting of this kind, and I'll come back to this, co-hosted by 3 institutions here in Indore. And I think the happiness that I want to express about is the synergy that is building up, both in terms of taking forward a frontline area to its logical destination, and also in terms of synergy between the programs and objectives of the three institutions that have hosted this conference. 2D MatTech Global, the science and technology related to 2D materials, is indeed, one can classify this as one of the very important emerging areas which has immense potential. Of course, there are 1D materials which have been explored, and we are kind of taking that area forward. We're talking about 2D materials in this conference. And of course, material science in general has been, I would say, a very strong point of Indian science. Of course, this is not my field, but being in atomic energy, one does get exposed to several aspects of development in almost all areas of science and technology. And I have been tracking in my career in atomic energy, and also later, I have been tracking the way India's progress is taking place in S&T domain. And this was particularly intense towards the later part of my career in atomic energy. The earlier part, of course, I was engaged in developing the pressurized heavy water reactor technology, which today is the main workhorse of nuclear energy momentum that we are seeing around. But then, as you know, the program has many more dimensions. The first stage, the second stage of fast reactors, and the third stage involving thorium reactors. And second stage work, of course, was being done primarily at Indira Gandhi Center. Of course, there is nothing hard and fast division. All centers, both within atomic energy as well as outside, have been contributing to this program in a significant way. For example, Rajaramana Center, which is a center for lasers and accelerator technology and related applications. But they have done a lot of work in seemingly mundane but extremely difficult and challenging aspect of repair and refurbishing of heavy water reactors. And I think, I'm not too sure how many of you have realized, but I think India is the first country, and maybe perhaps in some areas only country, which has applied, for example, the advanced laser technologies in actual maintenance of real-life power plants. So there are many examples, but what I'm trying to say is any development in science and technology anywhere finds applications, and in fact high-impact applications in many other areas. So coming back to my thought process during that time, So the transition from having put PHWR on a soundtrack and seeing fast reactor technology well on its way at Indira Gandhi Center, I was naturally concerned about the third stage, thorium, what is it that we can do? And it is then that it dawned on me that while PHWR technology, we had something which has happened earlier in Canada, for example, and that was a kind of benchmark for us to develop. Fast reactors, of course, the experience, international experience, even more limited, but there was some. And then I realized that in terms of thorium, there is no experience outside. The thing that bothered me at that time was that if you look at the track record, if you look at the whole history of S&T development in the country, so I asked myself, that can we visualize that this will happen in India on its own? So in that inquiry, the question that came to mind was, let's find out what very high impact making technologies we have developed in India in recent times. Those are first time in the world, ahead of anybody in the world. And I found that's a very hard question to answer. Going deeper into this issue, I started exploring the reasons for that. And the reasons, to my mind, they came down all the way into our education program, the research activities. Then I started looking, for example, Department of Science and Technology publishes science, technology, innovation indicators every year. And if you track that progress, there is a very steep rise, excellent performance. STI indicators in the country have been very rapidly going up. We also found that innovation experience is very rapidly growing. I think good performance is taking place. But when it came to large platform technologies, I found that there is something missing. And it is from that point onwards, this question of migrating from individual effort or individual group effort to bringing synergy, creating an ecosystem, creating a very fertile ground where the research translation from basic research to products in the high-tech area should or could happen in a systematic way, in a manner where everybody derives a lot of joy, a lot of happiness through collaborative efforts. It becomes a win-win situation for collaborators. And that has been engaging me in engaging with various institutions, academic, research, and others, including creation of some institutions. But that has been the focus. Tracking developments abroad, India has progressed. If you track our own progress over years, I think we must be very proud. The progress is indeed very spectacular. But then the world also is moving. And then I think we should also track India's progress vis-a-vis progress in the world. And see, we are living in a very competitive world. And so our progress must be such that we bridge the gap between us and quote unquote more advanced countries in the world. And that's what, because for a country to be counted in this competitive scenario, I think it will depend on how many new impact-making technologies that a country can bring out ahead of others. That is what will determine the economic strength of the country. That is what will determine the military strength of the country. And so in that context, if you scan what is happening elsewhere, primarily in United States and the China, the two are the most advanced countries in as far as, this movement towards the future. Industries, the companies and the countries which are really making great strides in terms of advancements are those where they have very leading, what one calls research-led industries. Just like research is an important component in an academic environment, important component of learning, important component of pushing frontiers of knowledge. But today, the competition, the cutthroat competition that is taking place all over the world, the research has become an important component of the industrial activity. And I submit to all of you that there are many areas which one may call cutting-edge research, but many areas where cutting-edge research in industries, not all, some of them in some countries, is actually on par or to some extent better than what is happening in the best of academic institutions. So this is a major transition which has taken place. And it's clear that maybe it's already happening or it's only a matter of time. Then the growth of economy, the so-called GDP growth, would be dependent on the contribution of research-led industries. So why I'm saying this on this platform is 2D materials is a perfect example of pushing these synergies, this domain, absolutely from very fundamental basic research all the way up to the products in many areas which have been mentioned. Maybe in energy, maybe in sensors, maybe in various aspects of environment, biotechnology, and what have you. And these things are happening so fast that many times there is, by the time you follow a linear progression between research happening in the lab, then collaborating with industry, then industry taking it to a commercialization level, that time is too long. And I think it's the concurrent working of all partners together that not only pushes the research towards or research translation, but it also creates a pull effect towards productization. And I think this is the synergy that one should be looking for. And so I'm very happy that, for example, the three institutions here in Indore, IIT Indore, Raja Ramanna Center, and the UGC DAE Consortium for Scientific Research, they not only bring different stakeholders with complementary interests, but they also offer complementary resources and complementary capabilities to push such areas forward. For example, these materials, it was mentioned earlier, do require characterization as you carry out this development. And of course, the best probes, of course, you require multiple probes, but within, for example, at RRCAT, you have the best of synchrotron facilities, X-ray probing in the country. At BARC, you can use neutron as a probe. And then there are facilities in all these three institutions which can allow various kinds of characterization, product design, product evaluation, performance qualification, and so on and so forth. And this is a framework we should create significant confidence in industry to sort of take interest, including investment, towards productization and make India a product nation. Here in this conference, we are talking in the context of 2D materials, but there could be many other areas, emerging areas of science and technology where similar things can happen. I will only leave, I'll make one more point and leave it with you, and that's it has no established science basis. But I still want to air a thought because I think it is very important. And that is, our concept of materials, materials and energy, these are the two things for supporting human life, for enhancing the quality of life for all of us. Talking about materials, today our whole kind of amenities, facilities, support system that we have, they're all based on products, on a class of materials. Call it metals of different kinds, call it plastics of different kinds. To some extent, we also talk about graphite, carbon fiber, and so on and so forth. It's clear that while iron or steel had made an impact and had become big, it's clear while plastics have made an impact and have become big, Today, we are talking about global warming. We are talking about somehow ensuring that the greenhouse gases are not let into atmosphere. But then human activity is so much dependent on use of fossil materials. So I think the fundamental challenge is, can we meet all our requirements, leveraging materials that we can, which are available in nature, and organize it in such a way that we don't let greenhouse gases into the environment. Now, on the other hand, we all know that carbon is a wonderful material. In various forms, right from at the nanostructure, microstructure level, all the way to bulk level, you get some wonderful properties. You want best of the tennis racket, you would want a carbon fiber based thing. Or you want best of a defense technology, you want carbon-carbon composites or carbon fiber composite. I know several colleagues who have developed chemical processes of producing some of these materials. For example, carbon nanotubes, or for that matter, graphene. I mean, one-dimensional, two-dimensional materials in bulk. They may not be so pure. They may not be good enough for example, some exotic applications, electronics and others. But there are many other properties to be explored, many other material forms which we require for day-to-day life, where these materials can in fact replace the current day use of steel, aluminum, plastic, and so on. Of course, structural plastic, I have no problem because that also immobilizes carbon, so that's okay. But the point is, as a group of scientists, can we think of research problems which will allow us to make or convert this adversity of carbon dioxide going into atmosphere as one of the greenhouse gases and creating the problem? We develop processes, both macroscopic as well as microscopic, where we develop applications right from exotic electronic or molecular applications all the way to bulk applications, where all that carbon is utilized and not allowed to go in atmosphere. Because, carbon capture and sequestration, or carbon capture, use and sequestration, is being talked about, very important, and today that seems to be the only solution. But then the quantities are so large that finding use for so much of carbon that we capture, I think, is next to impossible. So we must grow the utility, you must grow the applications. And that is where I think there are infinite number of research challenges. And I think it could be explored. It could be explored by, at least at a fundamental level, it could be explored. If somebody gets a bright idea, you could do work to test it out and see what can happen. And I know it's an uphill task. For the first 5-10 years, nothing tangible is likely to happen unless you suddenly get a breakthrough, which also might happen. So I thought, as we are talking about materials, and particularly 1D and 2D materials, I think India, with large number of researchers, in terms of our proportion of our population, the number of researchers may be low, but in absolute term, India's research community is quite large. Elite institutions like the three and many others which are represented here through all of you present here, I think we have a job, a social responsibility of not only pursuing our work, but also carrying the rest of the system along and develop frameworks where we do research to pursue activities in a focused manner, consistent with our own ideas, and create a culture, a science culture, which I'm sure it will take time, but once you develop a right ecosystem, it would take us forward and help us becoming one of the leading countries. We already are, but I think we have to still cross several steps on this ladder. But I think we must not lose opportunity. When other countries are going faster, we should also gain momentum. Because I come back to where I started, I didn't find any answer when I was exploring that question. In fact, India being so strong in material science, we actually missed the whole microelectronics revolution. I'm not saying that only scientific community is responsible. The whole country is responsible. But we must do our bit and also guide the rest of the stakeholders in the country to address this. We missed that. High temperature superconductivity, we missed that. Nanoscience, nanotechnology, that's an era we are in. Let us not miss this time and make sure that we join our hands together and make a success for the national good. And I compliment all the three organizing institutions and indeed all of you to be a part of this process in the context of 2D materials and related science and technology. I wish you good luck in your pursuits. Thank you.
Thank you so much, sir. Thank you for that enlightening and thought-provoking inaugural address. Your words have inspired all of us and set an excellent tone for the conference. So I request everyone to please give a huge round of applause for the sir. Thank you. As we draw the curtains on this memorable event, I would like to invite Dr. Ravindra Jahangir, sir, for the vote of thanks.
Namaskar. Respected Padam Vibhushan Dr. Anil Kakodkar, our Honorable Chief Guest, distinguished dignitary on the dais, eminent speakers, delegates, faculty members, researchers, students, and all. It is my pleasant privilege to propose the vote of thanks on behalf of the organizing committee of 2D MedTech Global Fundamentals to Application 2026. At the outset, I express our sincere gratitude to our Honorable Chief Guest, Padam Vibhushan Dr. Anil Kakodkar, for gracing this inaugural session and delivering an inspiring address. His insightful thoughts and words of encouragement will undoubtedly motivate researchers and students working in the field of advanced materials. I extend my heartfelt thanks to all the distinguished guests, dignitaries on the dais for their gracious presence and for sharing their valuable perspective, which have set the tone for the scientific deliberation that will follow during the conference. I would like to place on record our deep appreciation to the IIT Indore, RRCAT, and UGC DAE Consortium for Scientific Research for coming together, for their support and collaborating in organizing this international event. I sincerely thank all the plenary and invited speakers, delegates, faculty members, researchers and students who have joined us from various institutions and organizations across India and abroad. Your enthusiastic participation reflects the growing importance and immense potential of research on two-dimensional materials. My special appreciation goes to the member of advisory committee for their supports, advisory committee, technical program committee, and organizing committee for their untiring supports. As Vincent Goff aptly said, great things are not done by impulse, but a series of small things brought together. This conference is indeed outcome of the collective efforts and dedication of volunteers and support staff, whose tireless efforts have made this conference possible. I also acknowledge with gratitude the support extended by our sponsors, exhibitors, and collaborating organizations. With these words, I once again thank all the distinguished guests, participants for being part of this important scientific gathering. I wish all the delegates a fruitful and enriching conference and hope that the interaction during the next 3 days will lead to new ideas, meaningful collaborations, and innovations that will advance the frontier of two-dimensional material research. Thank you all.
Thank you, sir. With this, we conclude the inaugural ceremony of the International Conference on 2D MedTech Global. On behalf of the organizing committee, I thank you, our distinguished guests and volunteers. May I request all the participants to kindly assemble outside the Nalanda auditorium for a photograph with our distinguished guests. Following the photograph session, all participants are cordially invited for high tea arranged nearby. We wish you a productive conference, engaging discussions, and many fruitful collaborations over the coming days. Thank you and have a wonderful day ahead.